Hello guys, we're going to use a simulation today, and this is on the PHeT website. We're in model, we're not on real molecules yet, we're on just model, and this is a really cool simulation software that shows you what molecules will look like. So I want you to click on molecular geometry and electron geometry. They're slightly different, but for now this is just linear. And I also want you to do show bond angles. So you can see here I've got a bond angle of 180 degrees because my molecule is linear. Say I add an extra atom, so I can add an extra single bond doing this. And that puts my angle to 120 degrees with three atoms around my central atom. If I remove everything and add in a double bond and then two single bonds, you can see it's also 120 degrees. So the double bond doesn't change the bond angle because we've still got three regions of electron density. So let's try add in. So that's 180 degrees. That's 120. If we add in a fourth, it's going to go, so this is the trigonal planar arrangement. If we add in another one, it goes to tetrahedral. And you'll see our bond angle of 109.5 degrees. This is how it's arranged in space. You can kind of see we've got that triangular base with just one sticking straight up the top. Okay? And you can move this around and you can look at it from different angles. Now, the simulation does allow you to add more bonds in, and there are names for them. And if you do my year 13 chemistry course, you can see all these types of molecules like octahedral, but that is not in the level 2 course, and because these molecules are a bit more complicated, so we're just going up to 4 bonds right now, which will be this one. Okay? And you can have lone pairs in here as well. So if I have two atoms, imagine this is my oxygen and these are my hydrogens for water, and I have two lone pairs, as water does. Just arrange so that looks like water. Our bond angle is 109.5 degrees because our electron geometry is tetrahedral because we've got four regions of electron density. So we've got the tetrahedral geometry, but our molecule is bent because we're only looking at the bonding regions when we name our molecule. If we have three bonds, we're a trigonal planar. So our electron geometry is trigonal planar as well. When we add in a lone pair, our electron geometry is going to go to tetrahedral because we've got four. And our shape is now trigonal pyramidal, so it's like a pyramid. See that? And our bond angle again is 109.5 degrees. So this would be something like ammonia. And what we can do is we can go to our real molecules and we can find ammonia, which is NH3. And there, it looks like that. We can look at our molecular geometry, trigonal pyramidal, our electron geometry is tetrahedral, and our bond angle is going to be slightly different from 109.5 degrees for reasons that you don't really need to know about. But basically, the lone pair sits slightly closer to the central atom, pushing these closer together than they otherwise would be. So we go to some other cool molecules. Let's go to methane, CH4. We get the nice tetrahedral. Water looks like this. Again, the slightly smaller bond angle because these lone pairs are pushing these bonding atoms together. So I think that's all I want to show you now. And have a go at messing around with this. It's a lot of fun. And yeah, I'll see you guys tomorrow.